All right, so I'm going to go through all the review problems that was just given to you, so you can use this video to help study. Remember, it's important that you understand this. The test is very similar to this, so if you can understand this worksheet and feel comfortable with this worksheet, then the test will be easy. If you don't look at this and you don't study it and you don't work on it, then the test is going to be hard. And maybe you have to do it a couple times. Maybe it's not just you watch this video and that's it. Maybe you try it on your own, then you watch the video, try it on your own again. And if you're still having trouble with the problems, then work it out again or come and see me. But if you put in the effort and the time with this review, you will be perfectly fine on the test. All right, so for questions 1 and 2, it asks you to simplify. And you're given I raised to some power. Right? There are 4 things that you will have to know for the test. That I is simply equal to I. That I squared is equal to -1. That I cubed is equal to -I. And that I to the 4th is equal to 1. When we go to I to the 5th, that is equal to I, which is the same as just a regular I. When we go to I to the 6th, it is equal to -1. So after we go through these 4, it starts to repeat. This will be 5, this will be 6, 7, 8, 9, 10, 11, 12, and so on. Now, it's tedious and long if you were to try and actually count those, like I was just doing there, especially if you're doing I to the 84th. That could take you a while to count. So what we can do is we can think about it. We have 4 different options that can happen because they start to repeat. We have I squared, I cubed, and I to the 4th. So what we do is we take our power and we put it over 4 because that's how many options we have. And then you rewrite it as a mixed fraction. So this goes into 21 5 whole times. There will be 1 remaining. The only number that truly matters in this case is our remainder. When it is a remainder of 1, it is the same as I. So that means I to the 21st is equal to I. When it's a remainder of 2, it is the same as I squared. When it's a remainder of 3, it's the same as I cubed. And when there's no remainder, so a remainder of 0 or no remainder, it is I to the 4th or 1. So when we take this next one, we do 84, we divide it by 4. Well, 4 goes into 84 21 whole times with no remainder. So that means that it is the same as I to the 4th. So I to the 84th is equal to I to the 4th, which is equal to 1. So this will be your answer for 1, and this is your answer for 2. All right, so for number 3 and number 4, which I'll do them separately, it asks you to state the number and type of solutions. So we're going to use a portion of our quadratic formula, which is called our discriminant, and that is b squared minus 4ac. And if this is greater than 0, then we have 2 real solutions. If b squared minus 4ac is equal to 0, then we have, I'm sorry, this is supposed to be greater than 0, so let me just erase this. So if this is greater than 0, then we have 2 real solutions. If it's equal to 0, we have 1 real solution. And if b squared minus 4ac is less than 0, then we have 2 complex or 2 imaginary solutions, and whatever you want to type or write for either one is perfectly fine. But you have 2 imaginary or 2 complex solutions. So the first thing we have to do is we have to set it equal to 0. Without setting it equal to 0 and writing it in standard form, we cannot use the quadratic formula, or we cannot find our discriminant. So first we have to do, after we set it equal to 0, which it already is for us, is identify our a, our b, and our c. And then we're going to plug it into b squared minus 4ac. So when we plug this in, our b, which is 5 squared, minus 4 times our a, which is 9, times our c, which is -4. 5 squared is 25. -4 times 9 is -36. -36 times 4 is positive 144, because negative times a negative. 25 plus 144 is 169. So our discriminant is 169, which is greater than 0. So then our final answer is we will have 2 real solutions. All right, the next one, it's not written in standard form for us, so we need to go ahead and set it equal to 0. So we will add over the 6. 6x squared minus 5x plus 6 is equal to 0. Then same thing as before, we need to identify our a, our b, and our c, because it's the same question. State the number and type of solutions. Then we're going to plug it into our discriminant, b squared minus 4ac, where b is now -5 minus 4 times our a, which is 6, times our c, which is also 6. Negative 5 squared is 25. 4 times 6 is 24. And 24 times 6 will then give me 144. So this is minus 144. So now in this case, it's minus because we only have one negative sign. These are two positive. And 25 minus 144 is equal to minus 119. And 119 is less than 0. So that tells us that there are two imaginary or complex solutions. All right, now on to the next problem. All right, so unlike number 3 and 4, for 5 and 6, you're asked to solve. So what does x equal? So we need to use, and you're asked to use your quadratic formula, which you will be given us, negative b plus or minus square root of b squared minus 4 times a times c, all over top of 2a. First thing we do is identify our a is equal to 5, our b is equal to negative 3, and our c is equal to negative 2. Then we're going to plug it in. So then we have x is equal to negative 3 plus or minus the square root of negative 3 squared minus 4 times our a, which is 5, times our c, which is negative 2, all over top of 2 times a, which is 2 times 5. Negative of negative 3 is positive 3, plus or minus. I'm going to do this off to the side. Well, negative 3 squared is 9. 4 times 5 is negative 4 times 5 is negative 20. Times negative 2 is positive 40. 40 plus 9 is 49, and the square root of 49 is 7. So it's 3 plus or minus 7 divided by 10. So once we see here plus or minus, it tells us that we have two different answers. So we need to go ahead and write this out. So x is then equal to 3 plus 7 divided by 10, or 3 minus 7 divided by 10. Well, 3 plus 7 is 10. 10 divided by 10 is 1. So x is equal to 1. Or 3 minus 7 is negative 4. And negative 4 over 10 reduces to negative 2 over 5. And that would be your final answer, or answers. All right, here you have x squared plus 11x is equal to 5x minus 12. Once again, you're told to solve using quadratic equations, so we need to set it equal to 0. And we want our x squared to be positive, so I'm going to subtract over 5x and add over 12. So I'm going to subtract over 5x and add over 12. So that'll then give me x squared plus 6x plus 12 is equal to 0. We're going to be using our x is equal to negative b plus or minus the square root of b squared minus 4ac all over top of 2a. So the first thing we need to do is identify our a is 1, our b is 6, and our c is 12. So we'll plug it in. X is equal to negative b, which is 6, plus or minus the square root, which is 6 squared, minus 4 times a, which is 1, times our c, which is 12, all over top of 2 times a. I'm going to do this off to the side. 6 squared is 36. Negative 4 times 1 is negative 4, times 12 is negative 48. So this is then equal to negative 12. Before we could stop and say, well, it's no real solution. Not anymore, because we know that the square root of negative 1, a rule that we learned, the square root of negative 1 is equal to I. So we can separate these as the square root of 12 times the square root of negative 1. I know the square root of negative 1 is I, and now I can look to reduce this 12. Well, 4 times 3 gives me 12, and I can take the square root of 4, so I can pull that out. So it's 2, and the square root of 3 remains. So this is then equal to negative 6 plus or minus 2 times I times the square root of 3 all over top of 2. And since 6, 2, and 2 are all divisible by 2, and they all have to be divisible by 2, not just one of them or two of them, but they all would, we can reduce all these by 2. So x would then be equal to negative 3 plus or minus I times the square root of 3. And that would be your final answer. All right, so for this one here, you're asked to simplify. So we treat our i's just like we will with our x when we are doing adding or subtracting or multiplying. So it's nothing different. Division is where it does get different. So what we would need to do first, though, is simplify. So we would need to distribute this negative and this negative 3 in. So it gives me negative 3i minus 4. Negative 3 times 4 is minus 12i. Negative 3 times negative 6 is plus 18. And now we need to combine our like terms. Well, 18 minus 4 is 14. Negative 3 minus 12 is negative 15i. So the answer is 14 minus 15i. And it's important, you must write your real number first, followed by the imaginary part. All right, so your final answer is 14 minus 15i. All right, the next problem is 7 minus 3i squared. So the first thing we have to do is you can do this different ways. I'm just going to do this way. I'm only going to do it one way, but you can do this multiple ways because we learn that anything squared, there's a formula we can follow where you can use Pascal's triangle. I'm just going to go ahead and rewrite it as 7 minus 3i times 7 minus 3i because this is expanding out the power of 2. And then I'm just going to go ahead and FOIL it. 7 times 7 gives me 49. 7 times negative 3 gives me minus 21i. Negative 3 times 7 is another minus 21i. And negative 3 times negative 3 is positive 9i squared. Now remember, if you recall in problem 1, I squared is equal to negative 1. So this we can rewrite as 49 minus 42i, and then this is plus 9 times negative 1, which 9 times negative 1 is minus 9. So then 49 minus 9 is 40, and then we have the minus 42i. Final answer. All right, now when you're dividing by an imaginary number, it's a little bit different, or it's actually a lot different than we would if we were dividing by x. So this is where it changes. However, it is identical as if when we're dividing by a radical or square root. So we're going to multiply by its conjugate. And the conjugate is where the real part stays the same, but our imaginary number changes sign. So we will multiply by 2 plus I over 2 plus I. We will then distribute. 1 times 2 will give me 2. 1 times I will give me I, so plus I. 5i times 2 will give me plus 10i. And 5i times I will give me plus 5i squared. All over top. There's a shortcut for this. 2 times 2 will give me 4. I'm just going to work it all out, but if you know the shortcut, you can. 2 times I will give me plus 2i. Negative I times 2 will give me minus 2i. And negative I times I will give me minus I squared. It will always, always, always cancel out our outers and our inners, so you don't actually have to do that part. Then I squared we know is equal to negative 1. So this is 5 times negative 1, or this is going to be equal to minus 5. This will be equal to negative 1, and since it's minus a negative 1, it's going to be equal to plus 1. So 2 minus 5 will give me negative 3. I plus 10i will give me plus 11i. And 4 plus 1 will give me 5. These are equivalent to each other, but just written in different ways. All right, just like with radicals, we can't leave that in our denominator. We can't leave I in our denominator either. All right, so for number 10, it's 10 divided by 3i. Once again, we're going to multiply by its conjugate. Well, our real number is 0, so this is the same as 0 plus 3i. So all we're going to do is just multiply this by a negative 3i. 10 times negative 3i is minus 30i. 3i times negative 3i is minus 9i squared. However, I squared we know is equal to negative 1, and negative 9 times negative 1 is going to be equal to negative 30i over 9. And then we reduce. Both of these are divisible by 3, so our final answer would be negative 10i over 3. All right, so for the directions for 11 and 12, it will say to first write in vertex form if need be, then graph. Well, this is already in vertex form for you. So we don't need to write it in vertex form because it's already there. So the first thing we have to do then is identify how is our vertex moving. Well, this is telling us we're moving 2 to the left, and this is telling us we're moving 6 down. So our vertex then is negative 2, 6, negative 6. So then we will create our table, and we will put our vertex right in the middle, negative 2, negative 6. Then we're going to pick 2 points that are directly less than it and 2 points that are directly greater than it. So negative 3 and negative 4. And negative 1 and 0. It does not matter if you put 0 and negative 1 on the top and negative 3 and negative 4 on the bottom. It's all the same. Right, then we're going to go ahead and plug it in. So y is then equal to 2 times negative 1 plus 2 squared minus 6. Y is then equal to 2 times 1 squared minus 6. y is then equal to 1 squared is 1 times 2 is 2, so 2 minus 6, or y is equal to negative 4. And as we talked about before, we know that this one is also going to be negative 4 because it is symmetrical. If you don't know that on just knowing it's symmetrical, then plug in negative 3 and you'll get the same answer. Then when we plug in 0, y is equal to 2 times 0 plus 2 squared minus 6. Y is then equal to 2 times 2 squared minus 6. Well, 2 times 2 is 4, times 2 is 8, so y is equal to 8 minus 6, or y is equal to 2. And the same thing, because it's symmetrical, I know this one's also going to be 2. If you don't know that, then plug it in and solve. Our vertex is at negative 2, 6, so 1, 2, 1, 2, 3, 4, 5, 6. Our next point is at negative 1, negative 4, so 1, 2, 3, 4. And then at 0, we're at 2. And then at negative 3, we're at negative 4, so it'll be here. And at negative 4, we're at 2. So we will draw our graph going through these. And make sure you draw your arrows. And just make sure when you draw your arrows that you don't cross over the next points, because when you cross over, you're saying that's what its value is. So make sure you're drawing your arrows here before you cross over. Right? And that will be our answer. We create a table and we plot our points. All right, the next one for number 12, we do have to rewrite it in vertex form. So when you're writing it in vertex form, especially when there's a number other than a in front of your x squared, you are going to group those two together, your x squared and your x. And then you're just going to write your constant by itself. Then you're going to factor out, if there's a number in front of here, you're going to factor that out, because we want our x squared to be a positive 1 in front. So that means y is equal to, and when we factor out the negative 2, we're left with x squared plus 4x. Now I'm going to leave a space so I can complete the square. And then we have minus 7 still. To complete the square, we take that middle term and divide it by 2. So then we square it, and that gives us 4. So we always add that inside of our parentheses. Now, before we go ahead and try to offset this, you have to think about, what are we actually adding or sometimes subtracting to this? So we think this 4 is actually being multiplied by this negative 2. So it's actually subtracting 8 from our problem. So we need to offset that negative 8. So out here, we need to add 8 to it. So it's not always just adding and subtracting. We need to think about, if there's an a out front, what effect that is having to what we're adding. So since negative 2 times 4 means that we're actually subtracting 8 from this, we need to go ahead and add 8 so we offset it. And then we're going to factor it out. So y is equal to negative 2. Remember, after we complete the square, it's always going to factor into binomial square. We can take the square root of x squared and the square root of 4, so it gives me x and 2. And whatever sign we have here is the sign that we put in between. And negative 7 plus 8 gives me plus 1. I'm going to move this down a little bit first. All right, now we just need to graph it. After we put this in vertex form, we have to graph. So this plus 2 tells me that we are moving to the left 2, and this plus 1 tells me we're moving up 1. So my vertex is negative 2, 1. I create my table, and I put my vertex in the middle. I pick two numbers that are less than it, negative 3 and negative 4, and two numbers that are directly greater than it, negative 1 and 0. And then we substitute it in. So y is equal to negative 2 times negative 1 plus 2 squared plus 1. So y is equal to negative 2 times 1 squared plus 1. So this will give me y is equal to negative 2 plus 1, or y is equal to negative 1. So if this is equal to negative 1, we know negative 3 is also equal to negative 1. Then we plug in 0. Y is equal to negative 2 times 0 plus 2 squared plus 1. Y is equal to negative 2 times 2 squared plus 1. So y is then equal to negative 8 plus 1, which is equal to negative 7. So if this is equal to negative 7, so is this negative 4. Now we're going to plot our points and graph it. So we're at negative 2, 1. We're at negative 1, negative 1. And we're at 0, negative 7. 1, 2, 3, 4, 5, 6, 7. And then we'll plot our other points. Here and here. And then we draw our graph. All right, and just make sure you draw your arrows and make sure you do not cross the next x point on your graph. All right, so for 13 and 14, it asks you to describe in words. So you're going to be given your equations just like this, and you're going to write it out in words. So what I would suggest you do is, as you're writing each part, cross it out so you know that you addressed it already. So our A is 3 in this case. And remember, when the absolute value of A is greater than 1, that means it's being stretched. And when the absolute value of A is less than 1 but greater than 0, that means it's being compressed. So we would say here that our graph is being stretched. You're supposed to say stretched by a factor of 3, but your book doesn't say that, so I didn't really require you to do that. But it's being stretched. The minus 2 means we're moving to the right 2, so we're saying right 2 units, or move right 2 units. And this plus 1 means we're moving up 1, so you'll say move right 2 units and up 1 unit. And that's it. Writing in words what's happening. You're not graphing it. You don't have to do any of that. You just need to describe what's going on. So I think it's easy if you cross out every single step along the way. Remember, if our A is less, so for 14, if our A is less than 0, that means it's reflected. So this first one here, we will be saying reflected, because it's letting us know that our graph is now facing downwards. Same thing as before, when the absolute value of A is greater than 1, that means it's being stretched. So this 3 tells us it's reflected and being stretched. This plus 6 means we're moving to the left 6 units. So we're moving left 6 units. And this minus 4 means we're moving down. So moving left 6 units and down 4 units. And that's your final answer. So you're only describing it in words. You're not actually going through and graphing it. You just need to be able to look at it and say what is happening to our parent function. All right, so for number 15, you are asked to find the equation of y is equal to a times x minus h squared plus k. And you're given the graph. So when you're doing this, you have to identify the 2 points that you're given. Here, they're giving us our vertex. So I know that my vertex is the points -1, -18. And then if you see here, this is our y-axis. And it tells me that at this intersection that it's equal to -16. And on our y-axis, we're not moving anywhere left or right for the x. So our x value is 0. So it gives us the point of 0, -16. And now we need to solve for this equation. All right, there are a few ways you can do this. Vertex, when you're given your vertex, we are given the points h, k. Yes, they represent x and y, but we denote them with the different letters h and k so that we can know that substitute them in for here. And this point is our x and y. So we have an h is -1, a k is -18, a 0 is x, and a y is -16. So we can sub it in. So now we're given y, which we know is equal to -16. And we're not going to use this y value because we know this y value actually gives us our vertex. So it's equal to, and the only variable that we don't know yet is a. So that's the one that we're going to leave as a variable. Our x is part of this equation, so it's 0. And it's not -1 because that -1 is actually our h value. So it's 0 minus our h, so minus -1, which is going to turn to plus, squared, plus our k, which we know our k is equal to -18. All right, it might be easier for you if you write this h and k on top of your points instead of below like I did, or next to like I did, just so you could see which one substitutes in for where. And now we just solve this. So -16 is equal to 0 plus 1 is 1. 1 squared is then 1a. You don't have to write the 1 in front of it, but it's 1a. And then we just need to solve for a. So we will add over the 18 so we can isolate our a. And a is equal to 2. So when we are solving and writing in vertex form, the 3 letters that we need to substitute in for are our a, our h, and our k. The x and y's remain x and y. So that way we can substitute any other values we want in to plot the rest of our points or to see what our y value is when x is equal to 10. So our y is equal to, we just solved that our a is 2. So y is equal to 2 times x minus h, which we know is -1, so plus 1, squared, minus our k, which is -18 or 18. All right, so that will be our final answer for this question here. All right, now the last question is, a stone was thrown from the top of a cliff 60 meters above sea level. The height of the stone above sea level, t seconds after release, is given by the function h of t is equal to negative 5t squared plus 20t plus 60. Find the following. So the two things that you have to realize here is they tell us t seconds. So that means our t is equal to our seconds. And it says our height is given by this function, so h of t is actually equal to our height. So when it says how high will the object be after 4 seconds, that means that we're substituting 4 in for t. We're saying t is equal to 4, and what is our height? So our h of 4 is equal to negative 5 times 4 squared plus 20 times 4 plus 60. 4 squared, 16. 16 times negative 5 is negative 80. 20 plus 4 is positive 80. They cancel each other out, so our h of t, or our h of 4, so our height after 4 seconds, is equal to 60 meters. So after 4 seconds, the stone is 60 meters high. For B, it says how long will it take for the object to reach 35 feet in the air? Or this should be 35 meters. Right, so what we need to do now is they're giving us the height, so that needs to be substituted in for h of t. So 35 is equal to negative 5t squared plus 20t plus 60. And when we're solving a quadratic equation, we need to set it equal to 0. So we subtract over 35 from both sides, and we will get negative 5t squared plus 20t plus 25 is equal to 0. Whenever we go to solve for this, we want our x squared, or in this case, our t squared, to be a positive 1. So that means I'm going to factor out my negative 5. So I'm left with positive t squared minus 4t minus 5 is equal to 0. Now, since we have an equation, I can get rid of that negative 5 by dividing it on both sides. And we get t squared minus 4t minus 5 is equal to 0. You can use any method you want at this point, completing the square, factoring, or quadratic formula. This is set up for us to factor nice and easy. So 1 times negative 5 is equal to negative 5. We put our negative 4 up here. What are numbers that multiply to negative 4 or negative 5 and add to negative 4? It'll be negative 5 and 1. We divide by 1, so that means it factors out to t plus 1 times t minus 5. We set them each equal to 0. And we solve for t. So we get t is equal to negative 1, or t is equal to 5. However, we're talking about how long it'll take for the object to reach 35 feet in the air. It doesn't make sense for us to say it will take negative 1 second. So you would reject this as your answer because it doesn't work in the context of our problem since time can't be negative, and it will only be 5 seconds. So the only answer for this one would be 5 seconds. All right, that is it for this review. If you have any questions, please reach out. And that's it.